Let us discuss various data types available in VHDL. Every data object in VHDL can hold value that belongs to set of values specified by using type declaration. So a type is a name that has associated with it a set of values and set of operations. Now certain types and operations that can be performed on object of these types are predefined in the language. First one is integer. So where it is the way it is declared in other programming language, same fashion, and the range is from 2 raised to 31 minus 1 to 2 raised to 31 minus 1 minus plus. Some of the allowable and frequently used predefined operators like plus for addition, minus for subtraction or division and multiplication, they can be used along with this particular data type, that is integer. Boolean is preferred type that has the values false and true, and some of its predefined operators are all the logical operators like and, or, and, nor, not. The declaration for the predefined types of the language are contained in the package called standard. The language also provides the facility to define new types by using type declaration, and also to define set of operation on these types by writing functions that return values of this new type. So by default, here we can use directly integer and boolean as we have just seen. Then next is major categories as far as these types are considered. First one is scalar type. So values belonging to these types appear in a sequential order. Second one is composite type. These are composed of elements of single type, that is like array, or elements of different types like records. So scalar is general one which we use frequently. Composite is whenever we want to declare array especially. Then third one is access type. These provide access to objects of given type, that is with the help of pointers. And file type, this provides access to objects that contain sequence of values of given type. So whenever there is one file declared, so in that manner we can access it like another programming languages. As far as scalar type is considered, the values belonging to this type are ordered, that is relational operators can be used on these values. Bit is a scalar type, and in general expression 0 less than 1 is valid and has the value true. So like this, there are four different kinds of scalar types like enumeration, integer, physical, and floating type. Integer type, floating type, and physical types are classified as numeric data types, since the values associated with these types are numeric. Enumeration and integer types are called discrete types, since the types have discrete values associated with these types. Then every value belonging to an enumeration type, integer type, or physical type has a position number associated with it. This number is a position of value in the ordered list of values belonging to that type. So we can see the example also. Uh, Now there is enumeration type like this. Enumeration type declaration defines type that has a set of user defined values. Say for example here type MVL is like a multi-value logic which we have seen, like uninitialized, 0, 1, high impedance, that is Z. So when we type defined as MVL, then it will automatically understand. Like another example is type micro operation is, so load, store, add, sub, MUL, div, that is multiplication, division. Say list we have defined, we can use it. So with the help of identifiers and literals, we can make the combination, and our own requirement wise we can define. Subtype, it may be say arith operation is, micro operation, range, add, to, div. So meaning is from this type defined set, we can access some limited set belonging to that type. Here subtype is a keyword. Arith operation is the new say type defined container, we can say. That container is going to access contents belonging to the container which has been named as micro operation, and out of that not all but in the range add to div. So that's why load and store will not be considered here as a arith or OP, but it will only consider start from add up to div, add, sub, MUL and div. It will consider here. So MVL is enumeration type that has the set of ordered values u, 0, 1 and z, for example. Now arith op is subtype of base type micro op and has range constraints specified to be from add to div. That is, the values add, sub, mul, div belong to subtype arith operation. Now this is integer type. As I mentioned, type index is range 0 to 15. Like this we can declare word length, say for example range 31 down to 0. Subtype data word length of, now subtype of that is named data word of the type word length. So like that we can declare, and so on. So this way integer can be declared. As far as physical type is considered, especially whenever any value that represents measurement of some physical quantity like time, length, voltage, current, we can use this. Like for example, here for current it is used in the range 0 to 1e9 and nanoampere, microampere, milliampere. So some definitions we can have and we can use it in this fashion. Here also we can use subtype. Subtype is applicable to all. Then comes composite type. Composite type represents collection of values, as I mentioned, like an array and record. So as and when required, we will use this at that time. In that session, you can better understand. For time being, just remember that an element of composite type could have value belonging to either scalar or composite or access. So that is important. So this is composite type. Then array type, as we have just similar to any other programming language, we can have an array like here address word is an array 0 to 63 of bit type, something like this you can declare. It is a plain array the way we use for any other language. Then record type, here only the difference is composed of elements of same or different types. So like here it is a pin type is range, something integer, and somewhere here size and time is mentioned. So that way mixed approach we can have. That is record type, not much frequently used as far as hardware design is considered. Then there is a access type. So here using pointer we can use, like type FIFO is an array and type FIFO PTR is access to this FIFO. So this FIFO pointer we have defined, and then it will give you the access. So PTR is an access type. The values are addresses that point to objects of type module, and every access type may also have the value null, which means that it does not point to any object. And the last one is file type. Conventionally for day-to-day programming it is not used, but you can have type vectors in the file of bit vectors, something like that, type names in the file of string, something like that. File type name, and then the file type and the file word. So like this we can declare it. So this is also vectors as a sequence from bit vector, like that we can use. Syntax wise it is file, file name, file type name, is a keyword, and mode. So this way you can declare. This is an example where VEC file colon vectors is in. Here you can declare the path, and then say for example file output names is out, std out. So like that you can declare it and you can use it. So in general, the mode of file in or out specifies whether it is an input or an output file respectively. Input files can only be read, while output files can only be written to. So this is all about as far as basically data types are considered. Thank you.